The story of Dr. Omar M. Yaghi, winner of the 2025 Nobel Prize in Chemistry, is one of perseverance, imagination, and purpose. From humble beginnings to international recognition, his journey shows how education, determination, and curiosity can transform not only a single life, but the future of humanity. From Jordan to the world, Omar M. Yaghi was born in Amman, Jordan in 1965 to Palestinian refugee parents who had very little. As a child, he discovered a book about molecules that captured his imagination and opened a lifelong fascination with science. At age 15, determined to pursue education, he moved alone to the United States. He started at a community college, learning English, working small jobs, and studying tirelessly. Despite every obstacle, he pushed forward with hope and grit. He earned a BS from SUNY Albany in 1985, followed by a PhD from the University of Illinois in 1990, and completed postdoctoral research at Harvard University. His career took him from Arizona State University and the University of Michigan to UCLA, and ultimately to UC Berkeley, where he is now a world-renowned professor and research leader. At Berkeley, Dr. Yaghi directs pioneering centers that combine chemistry, artificial intelligence, and data science, aiming to invent new materials to solve some of humanity's greatest challenges: climate change, water scarcity, clean energy, and sustainability. A new science, reticular chemistry. Before Dr. Yaghi's work, creating new solid materials was often a guessing game. Scientists mixed chemicals, heated them, and hoped for something useful. Results were difficult to predict or repeat. Dr. Yaghi revolutionized this process with a new field he called reticular chemistry. It introduced a simple but powerful method for building materials like architects design buildings, using strong, predictable connections. The steps are simple. Choose sturdy building blocks, metals as corners, organic molecules as linkers. Design the shape or framework you want. Connect the pieces with strong bonds to create a stable, porous structure. This discovery gave rise to metal organic frameworks, MOFs, materials with microscopic pores that can trap, store, and release gases and molecules in remarkable ways. Scientists can now design these materials on paper and then build them in the lab with precise control over structure and function. Today, there are tens of thousands of MOFs, each with unique features and uses, from cleaning air and water to powering the next generation of clean technologies. How MOFs help the world, Dr. Yaghi's innovations are already being used to address real-world challenges in climate, water, energy, and health. Fighting climate change, capturing carbon. MOFs can absorb CO2 from power plants or even from the open air, using less energy than traditional methods. This could make carbon capture cheaper and cleaner. Storing clean energy. MOFs can hold hydrogen or methane gases safely at lower pressure, making fuel storage lighter and more efficient for clean energy transport. Making water from air. Some MOFs can pull water from desert air, absorbing it at night, and releasing pure water when warmed by sunlight. Field tests show that a single kilogram of MOF can produce a cup of clean water per day, while larger systems can make liters. This breakthrough could one day bring safe drinking water to people in the driest regions on Earth. Cleaner and smarter factories, MOFs, are transforming how industries produce materials and chemicals. As catalysts, they make reactions faster and cleaner, reducing waste. As filters, they can separate gases or liquids more efficiently than energy-heavy distillation methods. Health and environment, MOFs, are also being studied for drug delivery, where medicine is stored inside tiny pores and released slowly in the body. Others are designed to remove pollutants like PFAS, forever chemicals, from water, offering a new way to clean and protect the environment. turning science into solutions. Turning discoveries into real products takes time, but Dr. Yaghi's field is advancing fast. Industry leaders like BASF now produce MOFs at industrial scale, hundreds of tons per year, for carbon capture and clean fuel systems. Startups such as Nuada, Mosaic Materials, and AirJoule are developing MOF-based technologies for air purification and water generation. Numat Technologies uses metal organic frameworks for gas storage in the semiconductor industry. As production expands, costs are falling, opening the door to widespread, affordable use. The role of artificial intelligence. At UC Berkeley's Bakar Institute, Dr. Yaghi is combining AI and machine learning with chemistry to speed up discovery. Since there are millions of possible metal and organic combinations, AI helps scientists predict which ones will perform best before they even begin experiments. This digital approach could one day allow smart laboratories to design and test new materials automatically, accelerating solutions to the world's toughest problems. A Nobel Prize that inspires the world. The 2025 Nobel Prize in Chemistry honors Dr. Omar M. Yaghi, not just for inventing new materials, but for creating a new way to build matter with purpose. His vision of designing materials atom by atom, guided by imagination and reason, has opened new frontiers in science and hope for a more sustainable planet. From a young dreamer in Jordan to a Nobel laureate at Berkeley, Dr. Yaghi's journey embodies what the MMMS Global Foundation values most: the pursuit of knowledge, the power of perseverance, and the belief that science and education can uplift humanity. As Dr. Yaghi often reminds his students, when you design materials, you design the future.